some classifications for triangles, starting with classifications by sides. And so when you have a triangle where all three sides are different, meaning there's no congruent sides, it's said to be scalene. So we can indicate that by taking three sides and putting different tick marks on each side. And so this is an example of a scalene triangle. All three sides are different. And if you have a triangle with at least two congruent sides, then that's considered an isosceles triangle. Okay, now notice the way that this is described here. Okay, it can be a triangle with at least two. So an isosceles triangle has two sides, but if you also had something like this, notice here, this is an equilateral triangle. It has all three equal sides, so we're going to see it here in the next definition. But that would also be classified as isosceles. This is not always the case. There are certain geometry texts where they say it's either isosceles or equilateral. This text, and what I've taught in the past as well, has it as both. So isosceles means two or more. And then an equilateral triangle is a triangle with all three equal sides. And so not only is an equilateral triangle what the word says, equi meaning the same, and then lateral refers to sides, but also the angles will be equal. And so that's just an extra sort of property with that. Okay? So what I want you to do is look at these examples right here in this question to the right and see if you can classify which of those would be the following. Okay? And the options here would be scalene, isosceles only, isosceles or equilateral, and equilateral only. And so those are sort of your options. I'm going to work my way from the bottom up because it's the top question is the one that's the sort of the tricky one. Okay, so when you look at this first one, 6, 3, and 6, what would that be considered? That one's isosceles, right? There's exactly two. Okay, it means that it's not equilateral as well. So it's only isosceles. Okay, what about the next one? 9, 11, and 14? That's scalene, no equal sides. 10, 10, and 10? Equilateral and isosceles. Again, this is the one that can sometimes be confused. But the last one is the one that's tricky for this because if you just look at the numbers 1, 1, and 12, it would seem like these are isosceles, right? But look at the units. 1 foot, 1 foot, and 12 inches. Right? Each of the 1 feet represents how many inches? 12 inches, 12 inches, and then 12 inches. Right? So be careful. Look carefully at the units for these because now you get equilateral and isosceles. Okay? And so in this particular case, you're not going to have one that's only isosceles, right? It's either isosceles only, scalene, or equilateral and isosceles. Right, so that's classifying triangles by the lengths of their sides or how many sides have the same length. You can also classify triangles by their angle measures. Okay, and so the three main classifications for that would be an acute triangle. That's a triangle with 3 acute angles. Okay, so if all angles are acute, remember acute means less than 90 degrees. So this would be an example of that. And here you're using sort of the eye test. You assume that it's drawn to scale. A right triangle is going to be a triangle with exactly 1 right angle. Now we'll talk later here about some of the angles in a triangle are limited to 180 degrees, and that means you can't have more than one right angle in a triangle, right? Because then there would be no degrees left for that third angle. So a right triangle is a triangle with a single right angle, and then an obtuse triangle is a triangle with one obtuse angle. And just like for the same reason, if you have an angle that extends beyond 90 degrees, and so again, you have all acute angles here, you have one right angle, you have one obtuse angle. You can't have more than one obtuse angle in a triangle. So it's limited to just one. And then finally, we saw an equilateral triangle by definition, and the word gives the definition. But this will have equiangular, meaning all three congruent angles. And for triangles, this will also be equilateral that we saw on the last slide. Okay, but that's equiangular if you're talking about or classifying its angle measures. All right, so just look at this top one really quickly. Classify those by one of these three here, not equiangular, just acute, right, or obtuse. Downs will help you decide what are the possible options for these. But if you look at the top one, are any of these angles here right or obtuse? No, they're all acute angles. So this represents the angles of an acute triangle. And what about the next row? You have 96. 96 is greater than 90 degrees, so this represents an obtuse triangle. Next row we have an angle with 90. That represents a right triangle. And again, these are all triangles here. Now, this last one is one that, again, with the drop down, you should be able to be intuitive about what it's asking for. But what kind of a triangle are you looking at if all the angles are 60 degrees? So this is equiangular, which means it's also equilateral. But that's not going to be one of the classifications when it comes to these three options. So 60, 60, and 60, are any of those right or obtuse? No. So this is also an acute triangle. All right, try this last question again, looking at the tick marks, and let the eye test kind of be, if you see an obtuse angle, it's representing an obtuse. But see if you can classify these using all 7 combinations of acute scalene, or scalene acute, isosceles acute, equilateral acute, again, both by side and by angle. Okay, so again, the drop downs are first by side, is it scalene, isosceles, or equilateral? And then by angle, is it acute, right, or obtuse? So there's 7 different combinations you can do for those. All right, so if we look at this C, B, A, and D, I've identified those 4 triangles here. When you look at triangle C, you have 3 tick marks, 3 tick marks, looks like 6 or 7 tick marks. There is a right angle. So by sides, you have 2 equal sides, which means it's isosceles, and then by angles, it is right. Okay. Triangle B, right here. Triangle B has 2 sides with 1 tick mark, 1 side with 2. And then when you look at the angles, so again, first based on the sides, 2 equal sides is isosceles. And then what do we know about this angle right here? It extends beyond 90 degrees, so you're dealing with an obtuse triangle. So isosceles, obtuse. Okay, triangle A, 1 tick mark, 1 tick mark, 1 tick mark. Equilateral. Okay, and equilateral is always acute. It can never be any other combination. That's why there's only 7 combinations instead of 9. okay, is if it's equilateral, then the only angle measures it can have are acute angles. And then finally D right here, you have 3 tick marks, 4 tick marks, 5 or 6, 5 looks like. So this is no equal sides, and it does have a right angle. So that is a scalene right triangle. So on something like this, you'll be asked to identify the remaining ones as well. E, if you were looking at this, is also scalene with an obtuse angle. F has 2 equal sides, so that's isosceles. These are all acute angles. And then G has no equal sides, and when you look at the angles, they're all less than 90 degrees, so that would be a scalene acute triangle. All right, so classifications, you have probably seen those before, and even if not, it should be pretty easy to distinguish between them. All right, the next couple slides here are going to be the slides that involve the calculations. Okay, the first is the triangle sum theorem, and there's a lot of different ways to prove this, but kind of proofs have been somewhat de-emphasized in this course. Okay, and what we're going to look at is just the theorem states that the sum of the measures of the angles in a triangle is 180 degrees. And again, most of you are already pretty familiar with this. So when you're calculating measurements for a triangle, you know that you're dealing with a total sum that is 180 degrees. So I want you to try these 2 questions here first. These are the 2 straightforward questions. And so go ahead and see if you can answer those knowing that the sum is 180. Remember, you can enter your answers as calculations. That's often going to be like an easier way to approach a question like this. However, if you do the calculations separately on a calculator or by hand, like that'll work as well. But it's easiest just to type in the actual calculation. So when you're working with problems like this, dealing with triangle sum, you might be given a picture. So here, looking at this diagram, you have 2 of the 3 angles. So the remaining angle is just going to be the total sum, 180, minus those other 2. So 40 minus 39. If you enter your calculation, it will give you your answer over here in the preview. But either of these ways to enter it are going to be accurate. And now, they may not give you a diagram, and they may just give you the information. If that's the case, you may want to sketch the diagram. So if you just label A, B, and C, notice it's not necessarily to scale, right? Although it's probably wise to sketch these to scale if you are going to do a sketch. So here, if you see that A is going to be an obtuse angle, and then you can just assign B and C. If you label what you have, 117, B is 13, and then you have your unknown C, which you can call by a variable if you want, or you can just leave it C. But you can also see from that your calculation is going to be a correct answer. So you take 180 minus the 2 given angles, and that's going to give you the preview of what's left, which would be 50. And so either entering the answer or the calculation would be acceptable for this. Right, so that would be the most straightforward type of question involving triangle sum. All right, the next type, like maybe going the next sort of level of difficulty, is going to be if you're given expressions for the 3 angles. And so I want you to try this before I talk you through it. See if you can find what is x equal to if you know these are the 3 angles of a triangle. We know that the triangle sum means that the sum of these angles, 6x minus 5 plus x plus 2x minus 4, has to equal 180. So if we write that expression again, here's our 3 different angles. When we combine these, 6x plus 1x plus 2x gives us a total of 9x. Negative 5 minus 4 is negative 9. That's equal to 180. What we can do here is add 9 to both sides. And then when we divide, 9 goes into 18 twice with none remaining. 9 goes into 9 once. So we get 21 for our value x. Now notice it didn't ask you to find what each angle was, although that's a possibility for a question type. Okay, here, just read carefully. Are you asking to solve for x, or is it a two-part question where you find x and then plug that back in to the remaining expressions? All right. Questions on those before we move to the item that is probably the most new to you guys? All right, so we worked with ratios before, right, on the supplementary angles and complementary angles. It's going to be the same idea for that, except now we have 3 parts to this. Okay, so you have the option of solving this by using part-to-part ratios or part-to-whole ratios. Okay, so if we're going to solve this first question using part-to-part ratios, okay, so I'm going to, again, kind of go through both of these examples. Okay, what this means is you're basically setting this up as being 3 times some multiplier, 5 times some multiplier, 7 times that same multiplier. So if you labeled what you have using part to part, you would get that 3x plus 5x plus 7x is equal to 180, and you can solve from there. 7 and 3 is 10, 10 plus 5 is 15x. Equals 180, or x equals, when you divide this through, you get 12. And so angle A, as you can see right here, is 5 times 12, so that would be 60. Angle B is 3 times 12, so that would be 36. And finally, angle C is 7 times 12, and that would be 84. So that would be one way that you can answer this question. So that's using part-to-part. This isn't the only way. And in fact, again, to me, part-to-whole ratios, if you understand them, will generally be easier to use. And especially when you can enter your answer as a calculation, because if I'm solving this question using part-to-whole, what I would see is I have 5 parts, 3 parts, and 7 parts. So how many total parts do I have? 7, 3, and 5 add up to 15 parts, right? So if I'm going to solve this using part-to-whole ratios, what I know is angle A is 5 out of those 15. Angle B is 3 out of those 15. And angle C is 7 out of those 15. And so it's just a matter of finding what is the whole. Right? So this is the part, the ratio of the part, to the whole. Well, the whole in a sum of triangles is what? 180. So the other way that you can enter this is to just calculate it in this way. Set up your part-to-whole ratio, multiply by what the whole is, which is 180 degrees for the sum of angles in a triangle, and you're going to get the same calculations that we got out here, right? 60 degrees, 36, and 84. And so either of those or any of those wind up working for you. All right, so that's using ratios. Be aware, you can choose either of the 2 methods, completely up to you. All right, the hardest version of the question here dealing with sum of angles in a triangle is this last question right here. So once again, I want you to try this. So the whole point in setting up this last question is to set it up in a way that you're using or describing every angle in terms of a single variable. Okay, so if we look at this first statement, C is 9 times A. So if we let A just be, angle A be A, we'll call it A. You can call it X or whatever you want, that's fine. But it says C is 9 times A. So I'm going to label C as being 9A. And then it says B is 8 more than 4 times a. So 8 more than means I'm adding 8 to it. Now, a lot of times what happens is students in like sort of interpreting verbal models, you guys tend to go in the order that you read it. So it says 8 more than. So a lot of times a student will put 8 plus. Now, it works for plus because the plus can come at the beginning or the end and it's not going to be any different. Okay? But if this had been 8 less than 4 times, then it would need to go at the end. So it's probably just useful to get in the habit of putting the adding or subtracting at the end of the expression. So 8 more than is going to go at the end of the expression, 4 times a. So 4a plus 8. Like I said, 8 plus 4a is the same expression, but if you had 8 less than, then 4a minus 8 would be the correct way to put it. 8 minus 4a would be incorrect. So it's best to just put the adding or subtracting at the end. So here's your 3 angles. You know that these add up to 180 degrees. So if we just combine these together, right, add them up. So if I add down a plus 9a is 10a, plus 4a is 14a, plus 8, that's going to equal 180. And then I can solve from here. Subtract 8 from both sides. I get 172. Divide by 14. So this is my a value, 172 over 14. Remember, I can enter my answer as a calculation. If I entered the decimal form, it would be approximately 12.29. But I'm going to use this number, the exact value for every calculation, and then I round it when I get my final answer. So C is 9 times 172 over 14, and you can reduce that fraction if you want, but you can leave it the same. And that's approximately 110.57. And then finally, we get 4 times 172 over 14 plus 8. There's our expression for B, and that would be approximately 57.14. So again, entering your answer as a calculation, to me, is always going to be the easiest process with my open math. And so I would recommend doing that. All right, questions on this, using triangle sum, that the sum of the angles in a triangle is 180. All right, the next slide is just a quick concept. You don't even really need to know this. You can solve this type of a question using the full triangle sum. But if you understand how right triangles work, the 2 acute angles in a right triangle are always going to add up to what? 90, right? Because if you say that A plus B plus the right angle is equal to 180, that's using triangle sum, then you know that those 2 acute angles are just going to be complementary. They add up to 90 degrees. So that is the relationship that you have right here. Measure of angle A plus measure of angle B is going to equal 90 degrees. The acute angles in a right triangle add up to 90 degrees. Okay, so what would be the value of x in this expression? $90 minus the 72, or you can do the calculation in your head and you get your answer of 18. All right, so try this last one here. Again, this is now back to your option to do part-to-part ratios or part-to-whole. And see if you can find what would these 2 measures be given the information provided. How many are using part-to-part? Okay. How many using part-to-whole? I'm going to walk you through both, but I'm also going to, again, suggest being able to do this part to whole like really simplifies what you have to do and allows you to answer the question pretty quickly and probably less likely to make a careless calculation mistake. Okay, so I'm going to start with part to whole. So if I have a part-to-part ratio of 9 to 7, how many total parts do I have? 16, right? So the whole is 16. So that means that A is the 9 out of 16, and B would be the 7 out of 16. We just need to determine what is the whole. Well, the whole here isn't the whole like some of the angles in the triangle. The whole now is the sum of these acute angles. And so what is that whole? 90. So there's our calculation. This would give us our answer. Again, I would leave it as a calculation. The preview will give you the decimal. Now notice it tells you or asks you to round to 2 decimals. But also notice that you have these terminating decimals here. Okay, you have exact values. Okay, there's a difference between an exact answer and an approximate answer. Okay, if you can write an exact answer with like 1 more decimal place, okay, or 2 more decimal places, I would recommend just write the exact answer. So writing 50.625 or 39.375, that's going to be exact answers. If you round this and you write 50.63 and 39.38, technically when you add those together, those rounded answers, it would be slightly more than 90 degrees. So when you write approximations, there's a chance for like a little bit of error. Both of those should be acceptable in the tolerance level, okay, but it's best to, if you can, write exact answers, which are either fractions, okay, or terminating decimals. Okay, but you could have also done this part to part. Sounds like a lot did, and that is if you look at this relationship right here, I'll call this A and B. What you could say is that A represents 9 times some multiplier. We'll call it X, but it can be any variable. And B is 7 times that same multiplier. Okay? We don't know what it is yet, but we know it's the same. This gives us the ratio of 9 to 7. Therefore, A plus B is equal to 90, which we can replace as 9x plus 7x equals 90. 16x is equal, 16x is equal to 90, divide by 16, and we get our x value here. If we substitute this in, 90 over 16, what we get is the same thing, just a slightly different version of it. 9 times 90 over 16, and here we'd get 7 times 90 over 16. And notice you're going to get the exact same calculations as what we got to start with. Okay? Whichever way works for you is what you should choose. Okay? I do encourage you, though, to try the parts of wholes. If it works, it's generally an easier process. All right, the final concept that we're looking at here today has to do with an exterior angle of a triangle. An exterior angle is found by extending the side of a triangle and seeing the angle on the outside of the triangle that's formed. So angle 1 right here, this is the exterior angle. Okay, these 2 angles right here, angle A and B, these are called remote interior angles. And what that means is they're the 2 non-adjacent interior angles. So when you look at angle C, so everything has to do with this one interior angle right here. Okay, so its linear pair is the exterior angle, and the 2 non-adjacent interior angles of that triangle, the other 2 angles of the triangle, those are called remote interior angles. Okay, and the relationship that exists is that the sum of the remote interior angles is equal to the exterior angle. So if you look at this first example right here, you have this exterior angle, x, and then you have this these 2 remote interior angles right here. So the shortcut for finding this measure of x is to just add those together. So x is going to equal the sum of those remote interior angles. So 63 plus 57. If you do the actual combination of those, you get 120. Okay, but that is the shortcut. Now here's what's going to happen. Okay? What's very likely is that when you guys go to solve these, you're not going to be thinking of it in terms of that. What you're going to do is you're going to likely use triangle sum right here to find that this is an angle of 60 degrees using triangle sum, and then you're going to use a linear pair, and you're going to find that this is 180 minus that other adjacent angle, and that would give you the 120. You can use either one. It's just a shortcut if you understand it, that the exterior angle is equal to the sum of the remote interior angles. So it might give you a chance to answer the question a little bit quicker than if you are going through and solving with triangle sum the whole time. All right, so try the question right below it. See if you can find what x would be based on that given information. So notice what you're looking at here. You have an exterior angle of 71 degrees, and that's equal to the sum of these two remote interiors. So 65 plus what is equal to 71? And so the answer is 6. That gives you your answer really quickly if you solve it that way. Now, again, not everyone's going to remember this when it comes time to answer this question on a quiz or a test. And so what is likely going to happen is you might see 171 and think, well, this linear pair is 109. If we use triangle sum, then 109 plus 65 plus x equals 180. And you can solve it that way. If you solve it this way, you would be adding 109 plus 65 is 174. So if you subtract 174 from both sides, you get the same answer. So you can still do these problems using triangle sum, but if you understand that the exterior angle theorem gives you a shortcut to work with, it might save you some time. All right, see if you can answer the two parts to this upper question, please. If I'm looking at this information, I see y is an exterior angle for this triangle, right? I extend my side through. So y is equivalent to the sum of these two angles. So all I'm going to do is put 79 plus 45. When I do that, I get my answer of 124. So this is the first answer, or the first part. Okay, to find x, now x is part of this larger triangle, and again, you can either think of this whole triangle, or you can think of just this triangle right here. So if I think that y was 124, I found that. So to find x, I can use triangle sum. Triangle sum means if I take the total sum of 180 and I subtract the two measures that I have. So I have a 30-degree angle right here, and I have that angle of 124 degrees that I just found. Okay, and when I calculate that, it will leave me with the solution 26. So those would be my answers. Now, what if I had used this whole triangle? So x is also a part of that whole triangle. So I see that x plus this 79 plus this combination here of 30 plus 45. So I could have also calculated this by taking 180 minus 79 minus, and then when I combine these, I get 75. And that would have also led me to the same exact calculation. Okay? So if we're looking at this diagram right here, you don't have to go in order, right? You don't have to find x first and then y. Find whatever makes sense to you or is easiest to find. And so to me, if I look at this, I see this triangle right here. And if I extend this side, y is an exterior angle. So y is going to equal the sum of these remote interiors. To me, that's the easiest first step. So y is 30 plus 74. Okay, so that is my first measure to find. And then after that, I can find x. X is part of this triangle. And so I can use triangle sum for this. And I can say that x plus 104 plus 49 is equal to 180. And so my calculation could be 180 minus those given angles of 49 and the 104 that I just found. And if I do that calculation, I get my answer to be 27. Okay, so that would be like this process. Now there's one other way that you could calculate x, and that is x is part of the calculation for this whole triangle, the whole outer triangle, that has an interior angle of 49, 74, and x plus 30. So you could have also said x plus 30 plus 74 plus 49 is equal to 180. And so I could have calculated this by taking 180 minus 49 minus 74 and then minus 30, and that would still give me the same values.